Hello and welcome. In this video lecture, we are going to learn the Venn diagram of the Arduino Uno board. Let's get started. On the screen, we have got a diagram of Arduino Uno. On the top left corner of the screen, where I am pointing with the cursor, we have got the power input. This is to be connected to an adapter, but beware of the allowed voltage. The standard is between 7 volts and 12 volts. I use 12 volts comfortable. The first bin is an empty void bin, which doesn't input or output anything. It is only for ensuring the future compatibility with other Arduino versions. The second bin, input-output reference, it is an output bin. It marks the high voltage. You know that computers use 0 for off and 1 for on. This can be used for signal comparison. Don't use it for input, otherwise you might damage the board. The next bin is the reset bin. It will reset the board and start the execution from the beginning. It's equivalent to pushing the button on the top right corner of the screen. The next two bins are the voltage output. They output 3.3 volts and 5 volts respectively. Next we have got two ground bins, and finally we have got the voltage in. It is the input voltage. You can use either the power supply socket, the USB socket, or this pin for powering up your Arduino board. Next we have got the analog inputs. There we have got 6 analog inputs. This is an advantage of a Raspberry Pi, where you need analog digital converter for reading data from sensors. Of course I mean analog sensors. Next we have got the ICSP, or the in-circuit serial programmer. They are used for connecting and programming other microcontrollers or other Arduinos. This is a nifty option to use. Whenever you try to use Arduino as a programmer, it will be connected to other microcontrollers like 8051 or BEC microcontroller, and then you use them to flash the program onto the other microcontroller. There is another ICSP, which is ICSP2, which is designed for the same purpose on the top right of the board and can be used again for connecting to other microcontrollers. Then we have got the RX and RT bins. They are the receiver and the transmitter. R for receiver, T for transmitter, and they are used for serial communication, for example with the ESP8266, which is a Wi-Fi serial module. Next we have got the digital input out pins from pin 2 up to pin 13. Sometimes we know that there is a tilde notation, which stands for pulse width modulation. It is useful for interfacing with sensors or actuators that allow us to communicate signals in serial instead of reading or writing one bit at a time. Next we've got one more ground pin and the analog reference or AREF pin. It is an input pin. It allows us to set the high signal value. For example, we may want to set high value to be 2 volts instead of 3.3 volts. It depends on the design of our circuit, but now you know there is an option to change the voltage level for the high value. Now that we have covered the Venn diagram, let's have a look at the datasheet of the Arduino Uno. In the previous video, we have referred to store.arduino.cc to get your own Arduino Uno. Click on the item and open the product details page. Scroll down and you'll find different tabs: overview, explanations, and documentation. You'll find details on how to use the board and so on. Under specifications tab, you will find the input voltage, which is standard between 7 to 12 volts. You will find different information such as the static RAM. Static RAM is the memory that is erased if the power is off. You find also information about the electronic erasable programmable memory, which is 2 kilobytes. You find about the microcontroller inside the Arduino Uno, which is at Mega 32 by 8, and also we find information about the clock speed, which is 16 megahertz. It's quite useful to know the clock speed so that you know the frequency your Arduino is functioning at. Under the documentation tab, you find the Eagle files and the schematics, which is a PDF, and let's click and open it in a new tab. Here we can see the detailed schema design of the Arduino Uno. You can reference it whenever in doubt of some functionality. And if you scroll down the page, you find some more hints, tips, and tricks for programming, pin mapping, interfacing, and so on. There are plenty of other unofficial references on the internet for the Arduino Uno. You can see here we've got an elevator view and button view. This one is the unofficial documentation, which is attached to the course material. And as you scroll down, you can see highlights of some more important information, such as the external interrupt, which is the topic of the next video lecture. You find also information information about the SPI, the Cellular Programmer Interface, and the 4 pins associated with it. For example, the Reset Select SS, the Master Output Slave Input MUSI, Master Input Slave Output MISU, and the Synchronized Clock used for serial communication. We will introduce these concepts in a future section when we use the Arduino as a serial programmer for a microcontroller at Mega 32 byte. One more software that I would like to introduce is the Fritzing. Fritzing is an open source for board and circuit design. I downloaded it for Linux 64-bit and I have extracted it the same way we have done for Arduino IDE. I have downloaded it and extracted it the same way we have done for Arduino IDE. After extracting the zip file, open the directory and open in a new terminal. Type down /f capital Fritzing or type tab for autocomplete, and it should start and update the components database. It has 3 tabs for board design and a tab for schematic design and another tab for PCB design or printed board design. Finally, the tab for the coding. On the right side, you have got all the components and the parts you will need for designing your own circuit. It is quite useful for brainstorming and presentations, and I will use it throughout the course for illustrating the circuit diagrams of our experiments and exercise. Thank you and see you in the next lecture.